And this generation does not intend to founder in the backwash of the coming age of space. We mean to be a part of it. We mean to lead it. He said because it is there. Well, space is there.
Hello everyone, welcome to episode 6 of The Space Show. I'm your host of always, Nick. Thank you guys. And if you haven't watched the last video on the solar eclipse special, give it a watch. I mean, it's a long video, but there's so much to learn. I mean, I go through the history of the solar eclipse, and there's so much actual news that, I mean, it was a long episode, I'd say so. And without further ado, let's just get straight into it. And now today is April 12th, Friday, 2024, and we're going to be covering the weekend and Monday. So without further ado, Friday. We're going to have the close approach of the moon in M45, and then Mercury is going to be at inferior solar conjunction. Very cool. And then tomorrow, which would be Saturday, we're going to have the lunar occultation of Beta Tauri, and then Centaurus A is well placed, as well as Omega Centauri is also well placed. And then also Monday, 136199 Iris at solar conjunction, and then the Whirlpool Galaxy is also going to be well placed. So deep sky people, give that a look if you can with your telescopes. And the launches, we have the Falcon 9 Block 5 USSF 62, and that was actually Thursday as I'm recording this at 10:25 a.m. And then we have the Falcon 9 Block 5 Starlink Group 6 through 49. That's going to be Saturday at 9 p.m. Eastern Time Zone. That's a good time to watch. And then the Long March 2D London Payload, that's going to be on Monday at 12:10 a.m. Not a bad watch time, I say. And then the USSF mission. In a previous launch that actually happened today, I'll show you in the video, which I'll have on the screen. The USSF 62 is going to be sending a weather system follow-on microwave satellite to low Earth orbit. An environmental satellite that will measure the sea surface winds, tropical cyclones, and much more. Very cool satellite. And then Peter Higgs. On April 8th, sadly, Peter Ware Higgs passed away at the ripe age of 94. Now, Higgs became an icon only 12 years ago. This is where he discovered the Higgs boson, often called the God particle. To put it in simple terms, our universe is kind of coated in this invisible cosmic syrup called Higgs field. When particles enter this field, they end up gaining mass and, in result, being slowed down by that. Without this, particles all around us would just move around at the speed of light, not allowing any time for the formation of atoms. And this exchange of mass, of course, would not go unnoticed because we cannot just destroy or create mass, especially when talking about particles. What actually happens is that the energy that it loses in turn of gaining mass, it turns into these particles called boson Higgs, or the God particles, which helped Higgs confirm this phenomenon does occur. This can be traced back to Einstein's E equals mc squared, as the energy is converted into mass in the form of these God particles. Well, these God particles are hard to see as they end up decaying so quickly, but they tell us so much. Well, this was confirmed by Peter Ware Higgs, even if it meant challenging a fundamental rule, that being symmetry. Now, symmetry is basically saying that particles' rules of nature should not change when you look at them or from a different angle you look at them. But sometimes this rule is not followed, especially at the subatomic level, I guess. Scientists thought that particles named W and Z bosons should have no mass at all. I mean, they just act as a particle to bring about the weak force, which plays a part in transforming neutrons into protons and emitting electrons. It almost acts like a glue, which transforms them into them between the two particles. Well, they found out these tiny W particles have mass, and it broke the symmetry. This led to the discovery of the Higgs mechanism, which explains how particles get their mass and why symmetry actually can be broken. Almost like saying at this subatomic level, hidden rules can show up. They're able to use the Large Hadron Collider, which is a particle accelerator, and Higgs truly made an amazing discovery, and it shows how there's always a way to challenge a rule. Curiosity wins. Thank you, Higgs. And then stars making messes, on to our next story. It was found that the more evolved the galaxy was, the more chaotic the collective orbits of the stars are. Why? Orbiting around the galaxy, our sun is pretty circular, but in other galaxies, the path could be greater than that degree angle of difference. I mean, elliptical galaxies are basically the result of a merger that causes the stars to be stirred up. That motion of the stars usually determines the size and rotation of it. Well, scientists have found that as the galaxy ages, the more chaotic these orbits get. This age does not refer to how old the galaxy actually is, but if it's actively forming new stars. Older ones have stopped forming these stars. In research, they found that these are not directly caused by factors like mass, but rather the galaxy's age itself. The age can be influenced by the environment, though. In denser environments, where there are more galaxies around, they tend to stop forming stars earlier and become older quicker. This is because of things like collisions, gas stripping, and interactions. We can definitely explore that deeper in another video. For a spotlight, I have a lot of spotlight ideas. So, yeah. And then we have NASA's Transiting Exoplanet Survey satellite has found yet another young star named HD 21997. It was said to be a Delta Scuti pulsator. These are actually very similar to Cepheids in a way that they pulsate in cycles which vary the brightness and dimness of the star. This pattern lasts less than the Cepheids though. Delta Scuti stars pulsate in cycles from about 20 minutes to 8 hours. HD 21997 is about twice as massive as our sun and has a disk of debris. The main point of this research will be learning about how the debris disk was formed around the young star and how they evolved. Debris disk is definitely top thing they're going to be looking at. And then Voyager 1. Haven't heard that name in a while, since November, right? NASA has finally discovered the cause of the communication breakdown in space that happened in November. This would be due actually to the corrupted memory in one of the spacecraft's PCs. This caused it to keep sending back unreadable data, so scrambled that they couldn't even communicate it. Again, because in the flight data subsystem, there was the discovery of a 3% memory loss. Some say this could have been because the memory chip was struck by a high-speed particle in space, or it could have just worn out. Since this issue is now found, they should be able to fix the transmitters now, which will take possibly months or days. So let's see how that goes with Voyager 1. Then electrons. Scientists want to learn more about the electrons that create the aurora borealis. Yet, there are limitations, so NASA has decided to work on a new instrument to help them. Instruments right now measure electrons by changing voltage, yet the capture rate is not that good, even though it's a millisecond. So NASA created the Acute Precipitating Electron Spectrometer, APES. This uses a strong magnetic field to sort electrons by energy levels and measures them every millisecond, which was much faster as the other one. The only thing is that it can only look in one direction, which leaves out a lot about how electrons move. NASA's developing the APES 360, which can see in all directions. They eventually want to use it on satellites to learn about the northern lights. And this will actually be tested in 2025, so I'll probably have that rocket launch posted in 2025. We'll see if I'm still at it. And Kushi University researchers have found some new information about how baby stars develop. Baby stars? Really? They're using a power telescope named ALMA to study how they grow. They discovered that they almost have somewhat of a sneezing mechanism? Sneezing? Where they release dust and gas and energy from their surrounding disk. The disk is filled with magnetic fields, but they could build up and get too powerful for the stars, so they found out a way to sneeze them out, as coined. This was observed in a star nursery named MC27, and these sneezes look like spikes extending from the disk. That's caused by the magnetic instability from interacting with all the gases inside the disk. Researchers will continue to study them, as they think this is actually pretty normal in the formation of baby stars. And I guess it was a little bit shorter than our normal video, compared to the last video at least, but please, if you haven't already, check out my latest videos, the solar eclipse special, for sure. Leave a like, a comment if you like, and share if possible, because it would really help me out. I want to be able to reach as many people possible, help them learn about what space is truly all about. So, without further ado, Thank you guys for watching, and I'll have another video up on Monday. So everyone remember, be bold, be original, be invincible.